I'm sorry I had to stop that last video very quickly, so I'm back. We were discussing this non-Elisa based data. So we can explore a little bit about sources of heterogeneity, but when I left I was clarifying, one of the things about this is what might be the sources of heterogeneity is in it possible differences between the tests. Have we got a situation where we might be comparing apples versus oranges within this group? I haven't looked at the data, but that might be something to think about. So we'll go and have a look at removing a couple of studies, but I'm less comfortable with doing that in this situation, but we'll have a look at it. So I'm going to have a look at removing this Hegazia study. And if we do that, we really see that we reduce the heterogeneity and reach the same conclusion that we have in the Asian countries and in the ELISA-based, that there's not an enormous amount of evidence that the seroprevalence in cattle is different to the seroprevalence in buffalo. Now let's go down here and you can see that we have the test of subgroup differences. This is asking whether the ELISA is different from the non-ELISA, and you can see that the answer is no. Now it's a little bit artificial because we have some studies removed. So if we can find a rationale, let's just first of all, I've removed those two outlying studies, this 46 and this 5.8. And I'm not saying that removing studies is a good idea, but when it comes to exploring heterogeneity, it is useful. What would be wrong is to not tell people that you did this. You've got to say, we found these studies, they were a source of heterogeneity, we removed them, and this is what the effect was. What would be inappropriate is to just never tell people that those studies existed. Because one of the really interesting things is, what is the heterogeneity? But if I remove those two outliers, what we see, if we look at the subgroup differences, is there's no evidence that the estimates are different between ELISAs versus non-ELISAs. We get that from this p-value and this I-squared. And if there's no difference in the subgroups, then we could combine the subgroups, and this third row from the bottom is the assessment of the heterogeneity if you just ignored the subgroups, which technically we can. Once I've removed those, I ignore those subgroups, and you can see there's not much evidence of heterogeneity. And so it looks like we can combine the summary effect. And then if we look at the summary effect and we ask the question, is there any evidence that the summary effect is different from 1? Well, the answer to that is no, because remember that the null hypothesis for this Z is that the prevalence ratio is equal to 1 and the p-value is 0.69. So clearly there's no reason to reject that null hypothesis. But just quickly I want to go through again, how I approach reading forest plots. First of all, I like to look at the subgroups, and I like to look at the heterogeneity in the subgroups. And then if there's studies that I think might be influencing the heterogeneity, then I might remove them to see that effect on heterogeneity. And if it looks like I don't have much heterogeneity, then I'll look to see what the effect is in the subgroup by interpreting this Z, which is this p-value, but I can also tell the same thing by looking at this summary effect measure. And I would do the same for this subgroup. Having looked at the subgroups, I then, if they're hugely different, I might not do any further analysis. I might stop there. But if it looks like they're telling me vaguely the same thing as I see here, that's how I interpret this data, then I might go down and look at the test for subgroups and say, okay, are the subgroups different? And here I have evidence that says, you know what, the subgroups don't look any different. So then the next analysis is, well, what if I ignore the subgroups and combine everything? Once I've done that, Then I look at the heterogeneity, and I see here, there's no evidence of strong heterogeneity. There's no evidence of strong heterogeneity, so that means I should be able to interpret the summary effect measure, which is 1.03, and a 95% confidence interval 0.9 to 1.98. So there's that. And although it's not necessary, I could go and look at the Z test and get a p-value for that, where the null hypothesis is that the risk ratio or the prevalence ratio is equal to 1. And here, there's no evidence to reject that null hypothesis. Now I just want to, there were a couple of questions and I want to check that I answered these. So there was a question around, when I use the subgroup ELISA or non-ELISA, I use the same study with different values for the outcome based on the diagnostic method. I'm not quite sure I understand that, because to me, are they the same group study with the different values for the outcomes? So if you're changing the ELISA such that in one study the SP cutoff is 0.4 and in another the SP ratio is 0.2, then that would not be valid. I mean, they have to be different studies. So if one study was an ELISA, if within the same study they had one group of animals that were tested on an ELISA and then they retested the same animals, I don't know, using an AGID, then that would be valid. But changing just the cutoff for the ELISA, I don't think that would be appropriate. For studies used the ELISA method, I found the I-squared was 4.8 and the p-value was 0.08. I think that we've answered that question, so I'm feeling that we probably don't need to touch on that. I think we've covered that. So I'm hoping that it's been helpful to look at these videos, and I'll look forward to any other questions that people might have for me.